Hello students, welcome back to today's class on integers, and today we're going to discuss about word problems. Word problems are very important because the algebraic expression or the integral expression with integers will not be mentioned. We need to understand the question, the word problem, and then we need to frame it. And if you do any small mistake in that, your answer completely will be wrong, right? Before going to word problems, in the last class we have just started what is a distributive property, but we couldn't discuss. So we'll discuss about distributive property and then we'll go for word problems, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session with distributive property. So what is that property all about? You can see here, distribute, the name itself says that we are distributing something to remaining people or to remaining numbers. You're distributing, you can see carefully here. What are we distributing here? What are we distributing? For example, B plus C is there, okay, and A is there. Three numbers are there. We are distributing A to both the numbers B and C with multiplication. It is not addition, it's not A plus, it is A into, that is again a big mistake you do. You always confuse with A plus B plus C and A into B plus C. Okay, A into B plus C, these two are two different things. You should not confuse between these two, okay. It is B plus C. In the first case, we are just adding all the three numbers. Associative property we discussed. But now, you are having multiplication as well as addition, two different operations in the same property. Two different operations, one with multiplication, one with addition. And we need to distribute whatever we are multiplying. We should distribute to remaining all numbers. You can see here, A we are distributing to B, so A into B, plus A we are distributing to C, so A into C. You should be very careful here. We should be very careful here. You have a positive between, okay, in between them. Don't try to multiply again these two numbers. What are we doing? A cross B, A into B, that is one term. Then this plus will come and then A into C. The same way here, if you carefully observe, this is one unit, C is another unit. So you need to distribute C to both of them. So you are distributing C to A, that is A into C or C into A, both are same. And C to B or B into C, both are same. We are distributing only the term which is being multiplied, not the thing which is added. You should be very careful in that. A into, when you are having into, that A should be multiplied, or to multiply for both the numbers, distributed for both the numbers. A plus B into C, that into C should be multiplied to both the numbers A and B. When you have the terms in bracket, it says that they are one unit. Whatever changes you want to do, you should do to the entire number inside the bracket, to all the numbers inside the bracket, correct? Let me give you small examples, okay? If you have 2 into 3 plus 5, okay, so that will be equal to 2 into 3 plus 2 into 3 plus 2 into 5. 2 into 3 plus 2 into 5. Don't again use addition or plus symbol in between them. It is the multiplication. So 3 2s are 6 plus 5 2s are 10. So that will give you 16. This is a 2 into 5 plus 3 is 8. 8 2s are 16. So 16 and 16, these two will be equal. 16 and 16, these two will be equal. Understand? Okay, so A into B cross C and A cross B plus A cross C, whichever number you are multiplying should be distributed to all the remaining numbers. Let me take one more example. 2 into 5 plus 6, so that is equal to 2 into 5, 2 into 5 plus 2 into 6 plus 2 into 6. So what is 2 into 5? 2 into 5 is 10 plus 2 into 6 is 12. So that becomes 22. 5 plus 6 is 11. 2 into 11 is also 22, right? The same way we can also go for the next one. What is that? 25 into 3 and 25 into minus 3. It is again the reverse way. 25 we are distributing to 3 as well as 25 we are distributing to minus 3. So using distributive property, I can write that as 25 multiplied by both the numbers 3 plus minus 3 plus minus 3. So what is 3 minus 3? 3 minus is 0, so 25 into 0. 25 into 0, so that will give you the answer as 0. 25 into 3 is 75, 25 into minus 3 is minus 75. So these two will make the sum equal to 0. These two will make the sum is equal to 0. Understand? So this is about distributive property. You have one more question. You can try to do that. Using the find the product using suitable properties, 26 into minus 48 and minus 48 into minus 36. You can see here minus 48 is common in both the cases. So you can try to apply from there. Here also 625 is common with a negative and positive. So please take care of that. Okay. So from there you can try to find the answer. Please try to do this. Now let's move for the most important thing in integers are the word problems. We have discussed a lot of properties till now. Lot of applications, lot of operations, how to add, multiply and subtract, divide integers. So with all this information, let us try to have a some questions on word problems. So what is the first question we are having? An elevator descends into a mine shaft at the rate of 6 meters per minute. Descends, what do you mean by that? Descends means going down. It's going down, okay. An elevator descends into a mine shaft. Mine means, okay, there is a mine area where you are mining, where you are doing mining. Okay, so it's moving down at the rate of 6 meters per minute. Per every meter, it is moving at a rate of 6 meters. If the descent starts from 10 meters above the ground, okay, so this is the ground here we were having. So above the ground, we are starting from 10 meters. From this point, the elevator is moving down. The elevator is moving down, okay. How long it will take to reach minus 350 meters? Minus 350. So you need to understand what is this negative. Sir, how can we have the distance as negative? See, the meaning of negative is always states that it is in the opposite direction. It is in the reverse direction. Positives are here, negatives are here, correct? In the same way, if you're saying positive is up, negative numbers are the bottom. Okay, so 10 and now it should move to minus 350 meters, at the bottom. So it should travel all this distance from this point to this point. So now tell me, what is the total length it is moving? What is the total distance it is covering? The total distance is equal to 10 meters above and although it is a minus 350, it is stating that negative means reverse direction, the distance is 350 meters only. The distance is 350 meters, it is a plus 350 meters. The distance is always positive. So plus 350, so distance is equal to 10 plus 350, that will give you 360. Distance equal to 10 plus 350, that will give you 360. So now the total distance that is being traveled by the elevator is total equal to 360 meters. But we should find how long it will take, means how many minutes or how many hours, what is the total duration of that journey at the rate of 6 meters per minute. Per 1 meter, if they are traveling 6 meters for 1 minute, for 1 minute, let me erase that and write minute. For 1 minute, let us say we are going at 6 meters. Then for 360 meters, how much time we are taking? Let me take this x, this duration as x. So how to calculate this one? You need to cross multiply. 1 into 360, okay, 1 into 360, which is 360, is equal to x into 16, x into 60. So how can you find x here? So the value of x will be 360 divided by 60, 360 divided by 60, so which will be 36 by 6, which is a 60, right? Sorry, once again, 360 is equal to x into 6, not 60, it is 6. Right. So 360 by 6, so you know that 6 ones and 6 are 36, so you will get total 60. What are the durations? What are the units? Okay, is it 60 seconds or 60 hours? You know that 6 meters per minute. The units are very important. When you say 60, when you're not mentioning the units, you don't know whether it is 60 seconds, 60 minutes, 60 hours, 60 days, 60 years. We don't have anything. We cannot say that. So always you should be very confident with the units. So it is minutes. Okay. So 60 minutes it will take to travel till minus 215, which is equal to 1 hour. Okay, 60 minutes or 1 hour, both are same. That is the total time it's taking to travel all this distance. Right? Let's move for the next question. What is that? The temperature at 12 noon was 10 degrees above zero. Above means positive. Above, upwards, okay, to the right, always it states that it is positive. 10 degrees above zero, 12 noon. What do you mean by 12 noon? It is 12 p.m., not 12 a.m. in the night. Noon, afternoon. Noon means afternoon, okay. Noon means 12 p.m. If it is decreasing, so at 12 noon, at 12 p.m., we have the degrees as plus 10 degrees. If it decreases at the rate of 2 degrees Celsius per hour until midnight, so it is decreasing at 2 degrees, okay. At every 1 hour, at 1 p.m., you will be having 8 degrees, correct? At 2 p.m., you will be having 6 degrees, so it is keeping on increasing. The point is, at what time would the temperature be 8 degrees below zero? Careful. It is not 8 degrees, it is 8 degrees below zero. That means at what time you will be having minus 8 degrees? At what time you are having minus 8 degrees? What would be the temperature at midnight? Midnight means middle of the night at 12 a.m. Midnight means at 12 a.m. Okay, we'll come back to this one. That is the second question. We'll come back to that. Let us try to understand about the first question. Starting at 12 p.m., it is at 10 degrees. From 10 to minus 8, what is the duration? What is the difference? Okay, so the difference in temperature is equal to 10 minus of minus 8. Difference of 5 and 3, 5 minus 3. 10 and 5, 10 minus 5. 10 and minus 8, 10 minus 8. Don't forget that extra negative. So that is 18. So total it should reduce 18 degrees. It should reduce 18 degrees. But how many degrees per hour it is being changed? 2 degrees, right? If it is decreases at the rate of 2 degrees per hour. So per 1 hour, if you have a change of 2 degrees Celsius, so how much time you need to have for 18 degrees Celsius? How much time you need to have till 18 degrees? It's very simple. 2 9s are 18, so 1 into 9, 9 hours. If you're confused, just take it as x and cross multiply. So 1 into 18 is equal to 2 into x. From here we'll get x is equal to 18 by 2, which is 9 degrees. 18 by 2, sorry, it's 9 hours. It takes 9 hours to reach to the point minus 8. So, starting from 12 p.m., if you go for 9 hours, where do you stand? From 12 p.m. to 1 p.m., 1 hour. To 2 p.m., 2 hours. To 3 p.m., 3 hours. So, that way, to 9 p.m., this is a total of 9 hours. From 12 p.m. to 9 p.m., it is a total of 9 hours. By that 9 hours, it will be decreasing by 18 degrees in total. But the initial point is plus 10, so it will reach to the final at minus 8 degrees. Minus 8 degrees, correct? So, at 9 p.m., the temperature will be minus 8. There is one more part of the question if you understand. What would be the temperature at midnight? Midnight means at 12 a.m. Midnight means at 12 a.m. Let me see that right once again. Right. Okay. So let me tell one thing here. At 9 p.m. you are having minus 8. So 10 p.m., 11 p.m. and 12 a.m. 9 p.m., 10 p.m., 11 p.m. and 12 a.m. So it is minus 8. Now 2 degrees less, you will fall at minus 10. 2 degrees, minus 12. 2 degrees more, minus 14. So at midnight, the temperature will be at minus 14 degrees Celsius. Right? From 10 to minus 8, you are having total 18 degrees Celsius as the difference in temperature. For every 1 hour, you have 2 degrees Celsius down. So total For 18 degrees, you need 9 hours of time. Starting from 12 p.m. to 9 p.m., you're having 9 hours, right? So you'll be falling at 9 p.m. minus 8, and at the midnight at 12 a.m. you'll be having minus 14 degrees Celsius. Understand? Right? Easy question. So let's move for one more question. A certain freezing point. Okay, once again go back. A certain freezing process requires that the room temperature be lowered from 40 degrees at the rate of 5 degrees Celsius every hour. Okay, so there is some procedure, okay, there is some process going on, freezing process. So what is the condition there? The initial temperature is 40 degrees, from there it is being reduced. It is decreasing at the rate of 5 degrees every hour till 10 hours. Okay, 5 for 1 hour, it is reducing at 5 degrees. It is reducing at 5 degrees. Okay. So for 10 hours, it will reduce by 5 into 10, 50 degrees. It will reduce by 50 degrees, correct? It is reducing. From the initial point, it has reduced 50 degrees Celsius. What is the initial point? 40 degrees. So from 40, if you are decreasing minus 50, okay, you should not go up because you are not increasing, you are lowered. Lowered means you are decreasing. That is the reason I am saying word problems are very important to understand and very easy to solve once you understand the question. Okay, so 40 minus 50 will give you minus 10 degrees Celsius. Minus 10 degrees Celsius, right? What will be the room temperature 10 hours after the process begin? So it will reach till minus 10 degrees. It has started at 40. From 40, after every 1 hour, if it is reducing 5 degrees, next it will go to 35, next 30, next 25, then next 20, and so on. After 10 hours, you will be at a state of minus 10 degrees Celsius. You will be at a state of minus 10 degrees Celsius, right? Easy question. Let's move for one more question. What is the next question we are having? In a class test containing 15 questions. Okay, you're writing an exam. The total questions you're having are 15 questions. The point here is 4 marks are given for every correct answer. 4 marks are given for every correct answer and minus 2 marks are given for every wrong answer, incorrect answer. It's not that you will get 0 marks for wrong answer. Here you are having negative marking. Negative marking means if you write wrong, you will lose marks. Okay. So, plus 4 and minus 2. That is the evaluation. If you are getting correct answer, plus 4. If you are getting wrong answer, minus 2. What's the first question? Bharati attempts all the questions. All means 15 questions. Okay. But only 9 answers are correct. 9 are correct. So 9 into 4, she will get 36 marks. But is this her final score? Had there been no negative mark for incorrect answer, that is her final answer, final marks. But as she is attempting all the questions, out of 9, you still have 6 questions unanswered. 15 minus 9. Out of 15, 9 are correct. So 6 are wrong. For every wrong answer, you are having a minus 2 marks. So 6 into minus 2 will give you minus 12 marks. So now your final score will be the addition of these two. Your final score will be addition of these two, 36 and minus 12. 36 and minus 12, you'll be having 24. See, 24 marks is her final score. Although she got plus 36, but due to the wrong answers, due to the incorrect answer, she has fallen to 24 marks, right? So once again, I'm saying, whenever in whichever exam you're having a negative marking, please don't attempt the wrong answer which you're not sure. Only attempt the answers which you are 100% sure, and that 100% sure means it should be correct. Only attempt. For example, there are 15 questions, and if, let us say you only know one question, just write one and come out. Don't try to attempt all which you don't know. Right? So let me discuss one more question, then we'll stop it here. So in the same case, okay, one of her friends, Hema, attempts only 5 questions. Only 5 questions. Only 5. So 5 into 4, how many marks are? 5 into 4 is 20 marks, and all are correct. It was given all are correct. What will be her total score? It is 20. See, in the previous case, what happened? Although the person got 36 with minus 12, she landed at 24, writing all the questions, getting 24, and writing only 5 questions and writing 20 marks. So which is best? I can say writing 5 questions and getting 20 marks is good than getting all your score is high, okay, but not always. When you're trying to attempt every question, when you're having negative in the competitive examinations, it will be very difficult task to keep up your score, because you'll be falling with the more and more negative marks, right? So please be very careful. So one more question, which I'm not going to do it now. I'm leaving this question for you, but just try to understand what is this question about. A merchant on selling rice earns a profit of rupees 10 per bag. Okay, he is earning rupees 10 per bag of basmati rice sold, and a loss of rupees 5 per bag of non-basmati rice. See, there is a rice called basmati, which you generally use for biryanis, right? When you see the biryani, you have a different kind of rice, a bit lengthy than the normal rice, okay, with a different fragrance, right? So a merchant is selling both basmati and non-basmati. How many bags? We still don't know that, okay? So for a basmati bag, he is getting 10 per basmati, so plus 10 is a profit. For a basmati bag, he is getting plus 10. And loss of rupees 5 per bag for a non-basmati. For non-basmati rice, loss of 5 means loss is again in the reverse direction of profit, so we keep a negative 5, right? So the point here is he sells 3,000 bags of basmati rice. So this one he is selling for 3,000 bags at a profit of 10 rupees per bag, and 5,000 bags of non-basmati rice in a month. 3,000 basmati and 5,000 non-basmati bags. So what is the profit or loss in a month? So I'm not going to do this one. You have every information given. Just multiply 10 into 3,000 and minus 5 into 5,000. Add these two. If you are getting a positive answer, that means you are getting a profit. If you are getting negative answer, that means that you are getting loss. Profit is always with a positive, and loss is always with a negative. So when you are getting negative answer here, you will be losing. You will get a loss, right? So one more question here. What is the number of basmati rice bags he must sell? Okay, so now we need to find the number of basmati bags. Okay, has to sell to have neither profit nor loss if the number of bags of non-basmati rice is 6,400. Non-basmati rice, you're having 6,400 bags into, for every bag you're getting a loss of minus 5 rupees, right? So you know how much is this amount. But to balance this one with neither profit nor loss, you'd have X number of basmati bags with plus 10 as a profit. Given. So these two should be equal. In terms of numbers. That means you should not have any positive or any negative. Then you can say that you're having 0 rupees profit or 0 rupees loss. You're not having neither in a state of profit nor in a state of loss, right? A beautiful application, so please try to do it yourself, right? So that's all with all the word problems here, and that's all with the chapter of integers. In the coming lecture, we are going to discuss about the next video, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So today we will be discussing about heat and temperature. We will be going into the basics of what heat and temperature are scientifically. Right now, you have a basic idea of heat and temperature, right? Because everyday life, nowadays because of COVID, you check the temperature every day. Yes or no? Right? So we will be going into that. So my name is Shashin Reddy. I'm a graduate from IIT NEET. Let's go into the class. So here, look at this. If I ask you this, what is the difference between winter and summer? There are many differences. Summer comes around March, April, winter comes around November, December, right? Many differences, right? I just gave you an example. But one of the basic examples is, we can say that winter is cold and summer is hot. Winter is cold and summer is hot. So we know what cold and what hot are. It's a feeling. We feel cold, we feel hot. Yes or no? So it's a feeling. So now, how do we define this cold and define this hot scientifically? That we will learn. Okay? Chalo. Now another simple question for us. There are two glasses of water in front of us. One is hot and the other is cold. How can we know which is which? How can we know which glass is cold and which glass is hot? That is, if I say this is glass A, this is glass B, so how do we know which is cold and which is hot? Now let's say it is not very hot, it's not very cold. Okay, then it's very simple, we can touch it. By touching, we can say one glass, let's say this it is hot. So when you touch the glass, you will feel hot. But when you touch this, let's say the cold glass, you will feel cold. So hot or cold, you can tell them by touching the glasses. You can tell that by what? Touching the glass. So touch can be a useful tool to understand whether a given object is hot or cold. So we can say that by touching it. Okay, that's good. But is it always reliable? That means by touching, can you always tell how hot an object is? Let's look into it. Okay, so first of all, we'll learn about something called as heat. Right, now see, when we touch a hot object, we feel hot. When you touch a cold object, we feel cold. Now what happens is, if this is a hot object, and if I am touching the hot object, if I touch the hot object, what happens is heat will flow. Heat is a form of energy. So heat will flow from the hot object, into our hands when I touch it. Into our hands when I touch it. Yes or no? Just a minute. Right? But the same thing when I touch a cold object. When I touch a cold object, what happens? Heat will flow from our hands. We will lose heat. That is the reason why we feel cold, from our hands into the cold object. So the main point is, when I talk about heat, I am talking about heat that flows. Heat will flow. Heat will flow. So heat, how do you define heat? Heat is a form of energy which flows from a hot body to a cold body. Always. See, when I am touching a hot body, it is flowing from the hot body to us because we are comparatively cold. But when I touch a cold body, who is hotter? The cold body or us? We are. So when I touch a cold body, from our body, heat flows into the cold object. So what is that? Heat is a form of energy. Very important. This is the definition. Heat is a form of energy which flows from a hot body to a cold body. Or else, we can also define heat in this way: the energy which makes an object appear hot or cold. Yes or no? Because How do we feel hot or cold? It depends on how the heat flows. If the heat flows into our body, what is that? See, heat flows from the object into our hands, it is hot. We get, if heat enters us, that object is hot. But if heat goes from our body to the object, that means it is cold. So heat is what makes it appear hot or cold. So heat can also be defined as the energy which makes an object appear hot or cold. In simple terms, one important thing that you have to understand is heat is a form of energy. Heat is a form of energy. Any definition, you have to mention that. Heat is a form of energy. Now, what are the other types of energy that you might have heard of? Energy from the sun, solar energy. Energy from light, light energy. Energy from sound, sound energy. There are different types of energy. Again, in fact, energy from food also. Energy in chemicals, chemical energy. Energy in current, electrical energy. There are different forms of energies. One form of energy, one type of energy is heat. And where does heat energy occur? Heat energy flows from a hot body to a cold body. Okay? Good. That's good. So you can clearly see the body that gains heat. Gains will mean it gets heat. So that gains heat becomes hotter, and the one that loses heat becomes cooler. Clear? Again, the third point is also an interesting one and an important one. So that is heat. Heat is a form of energy. Now there comes something called as temperature. What is temperature? We'll understand. But before that, let's go into this. Have you anytime touched a bulb? We are taking an incandescent bulb. These are the old type of bulbs, the orange bulbs. So have you touched an incandescent bulb anytime? I mean, obviously when it is glowing. Or let's say you have switched on the bulb for some time, switched it off, and then you are touching it. The bulb will feel hot, yes or no? If you touch the bulb, you will feel that it is hot. Okay. Then I'll go into this. Have you touched a pot of boiling water? So here you have an incandescent bulb. Then here you have a pot of what? Pot of boiling water. So when you touch the bulb, you will feel hot. You will feel that the bulb is hot. When you touch the boiling water again, then also you will say that the boiling water is hot. By touching, you can tell whether an object is hot or not. Now the question is, which is hotter? The question is, which is hotter? The boiling water or the bulb? The bulb that is glowing. Which one is hotter? Right, now that, how do we say? See, if I touch this boiling water, I'll feel hot. If I touch this, I'll again feel hot. But I cannot say which is hotter only by touching. No, very difficult. So in that case, or for those purposes, we define temperature. So using temperature, we can say how hot an object is or how cold an object is. Okay, temperature is a measure of hotness or coldness of a body. Nowadays, when you go to, let's say, any shopping mall, any place outside, they measure your temperature. Yes or no? They use a thermometer to measure temperature. Your temperature might come around 98.6 degree Fahrenheit, 99 degree Fahrenheit, normal temperature. But if your temperature is 100 degree Fahrenheit, you have a fever. 100, 101, 102, very high fever. Yes or no? So as temperature increases, your fever is more dangerous, more drastic. Yes or no? So why do we use temperature there? To measure the hotness of the body. So temperature is a term, is a quantity that we use to measure how hot or how cold a body is. To measure the hotness or coldness of a body. So understand, heat and temperature are completely different. Heat is a form of energy that will flow from a hot body to a cold body. But how much hot a body is, how much cold a body is, we tell using temperature. Got it? So temperature measures how hot a body or how hot a body is or how cold a body is. Clear? Good. So to measure which is hotter here, we can use a thermometer, measure its temperature, then we can say which is hotter. Not by touching it, by touching we cannot say exactly, but using a thermometer or by measuring their temperatures, we can exactly say which is hotter. Okay? Good. Let's continue. Now the question is, we learned about temperature, we learned its definition, we learned what it means. Then how do we measure it? Now we'll go into that part, the measurement of temperature. But before that, let's go into something. Now, when we measure height, generally, in which units do you measure height? Yeah? In which units do you measure height? We can measure it in terms of centimeter. Generally that happens. Generally, we measure in terms of centimeter or in terms of inches. Foot and inches, right? 6 feet. Or you can say 4 feet, 3 feet, 4 feet, 5 inches, 3 feet, 10 inches, 4 feet, 6 inches. Yes or no? Or 2 feet, something. So we measure height, we can measure height in terms of centimeter or in terms of feet and inches. Yes or no? Right? So, simple, I have mentioned the point. Now here for height, measuring height, we have different units. Similarly for temperature also we will have different units. For temperature also we'll have what? Different units. And for every unit we define a scale. You'll understand what scale is. As of now, understand it as different units. So for temperature, what are the units or what are the scales? For temperature, you have the basic one, the Celsius scale, the Fahrenheit scale, and the Kelvin scale. You have 3: Celsius, Fahrenheit, and Kelvin. We'll go into each and every one of them, then you'll understand them very clearly. Okay. So before we go into Celsius, Fahrenheit, and Kelvin scale, let's understand a few points. Let's go into something called as boiling point of water. Now what is boiling point, everyone? We say water is boiling, but what is boiling? The boiling point or the phenomena boiling is the conversion of water into water vapor, into steam, into a gaseous form. Yes or no? So the temperature at which water converts into steam is called as what? Is called as the boiling point of water. And what is the boiling point of water? It is 100 degrees Celsius. But the same thing in different units. I told you, right, there are different units. So it's like my height in centimeter is 178 centimeter, but in terms of inches, I'll just give an example. Okay, my height is 178 centimeter, or the same thing in terms of inches is, I think it is 5 feet and 10 inches. Okay, 5 feet and 10 inches. So if I look at this in centimeter, there is a different number. In feet and inches, there is a different number. Yes or no? So depending on the units, there will be different numbers. So there are different units. This is called as degree Celsius. The boiling point is 100. In terms of degree Fahrenheit, it is 212. In terms of Kelvin, it is 373. So different units, you have different numbers, different values. Okay? Good. So similarly, you have something called as melting point. What is melting point? We say that ice melts. What happens when ice melts? Ice will be converted to water. Yes or no? So when we say melting point or the phenomena melting, we are talking about conversion of ice into water. Generally speaking, solid into liquid. So the temperature at which ice converts into water, is called the melting point of ice. And do you know what the temperature is? The temperature is in terms of Celsius 0, in terms of Fahrenheit 32, in terms of Kelvin 273. Those are some values that you have to remember. We'll go into those values, don't worry. Okay, but that's melting point and boiling point. Melting point of ice and boiling point of water. Clear? Okay, that's good. That's good. Let's continue. So now we'll go into the units of temperature. We'll first start with Kelvin. Now why are we starting with Kelvin? Because the SI unit of temperature. The SI unit of temperature is Kelvin. The symbol is capital K. Now you might think, sir, normally I have heard about Celsius, I have heard about Fahrenheit. What is Kelvin? Kelvin is mostly scientific. Okay, in everyday life we use Celsius and Fahrenheit, but Kelvin is the proper unit and it is the SI unit of temperature. It is the SI unit of temperature. And Kelvin is the name of a scientist, a very famous scientist. Okay, that is the reason why its symbol is capital K. Got it? Now we have other units also. See, for Kelvin the symbol is capital K. For Celsius we have what? Degree Celsius. Do not forget this degree. This is important. When you write it down, the degree is very important. For Kelvin, no degree. It's a very important thing. For Kelvin we have no degree, but for Celsius and Fahrenheit there is a degree. So degree Celsius, degree Fahrenheit. So these three are the most used units. Kelvin SI unit, degree Celsius and degree Fahrenheit, other units which we use regularly in our everyday life. Okay, good. So I'll start with degree Celsius. So for every unit you have to understand this. The melting point and boiling point. Okay, it is something that is defined. Okay, now the Celsius was also a name of a scientist. Okay, Celsius is also a name of a scientist. So this scientist Celsius, he thought, there is melting point of ice, there is boiling point of water. So melting point I'll take the temperature as 0, boiling point I'll take the temperature as 100. And he equally divides the temperatures between them. So it's like a scale. It is like a scale. See, just a minute. So if I take a scale, you can take a 15 centimeter scale. At one end you have 0, at the other end you have 15, and then you're equally dividing the length of the scale into how many parts? Into 15 parts. Yes or no? That's how a scale will be. Let me again draw it. If this is a scale, this is 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, 11, 12, 13, 14 and 15. So we take the length of the scale and we are dividing it into equal parts. And how many equal parts? 15 equal parts. So we are dividing the length. Similarly, for us, we are dividing the temperature between the ice, the melting point of ice and the boiling point of water. Into how many parts? 100 equal parts. Like 100 minus 0, that's it. Just subtract 100 minus 0 is equal to how much? 100. So you divide that into 100 equal parts. That's it. Okay, that's what Celsius has done. Now, Celsius took melting point of ice as 0, boiling point of water as 100. Now you might say, sir, I will define a unit. I'll take melting point as 10. I'll take boiling point as 50. Can I do that? You can do it. You can call it by your name. Okay, you can do it. But regularly, or the standard ones are this. Celsius is one of the standard. Where melting point of ice is 0 degrees Celsius. Boiling point of water is 100 degrees Celsius. And how many parts do we have in between? 100 minus 0, 100. Number of divisions between the melting and the boiling point of water, 100 minus 0, it is equal to 100. Clear? Understood? Okay. Now you might ask me, sir, why did Celsius, the scientist Celsius, take the melting point of ice as 0? It was up to him, he decided it. Why did he take boiling point of water as 100? It was his choice. Okay. Then you have Fahrenheit also. Fahrenheit again. Fahrenheit is also a name of a scientist. But we call it as degree Fahrenheit. So according to Fahrenheit, what did he do? He took the temperature of melting point of ice as 32 degree Fahrenheit. How much? He took the number as how much? 32. I told you, right? It's up to us. So it was up to Fahrenheit. He took it as 32. And boiling point, they took it as 212. And how many parts is it equally divided into? You have to subtract 212, the boiling point of water and the melting point of ice. 212 minus 32. Do it, everyone. Subtract 32 from 212. What will you get? 32 from 212, you will get the value as how much? 180. 180, 212, 32. Subtraction 2 minus 2, 0. You have 1, 3. So 11 minus 3, 8. 2 becomes 1, 180. Clear? So that's the thing. You can just say 212 minus 32 is equal to 180. So the melting point of ice 32 degrees Celsius, 32 degree Fahrenheit. The boiling point of water 212 degree Fahrenheit. And the number of divisions between them, how many is that? 212 minus 32, 180 divisions. And do not forget that for Fahrenheit, you have to take it as degree Fahrenheit. Degree Fahrenheit. Very important. Degree is very, very, very important. Okay. These are some things that we have to remember. No option. Okay. For Celsius, melting point of ice is 0. The boiling point of water is 100. For Fahrenheit, the melting point of ice is 32. The boiling point of water is 212. You have to remember. Okay. Then comes Kelvin scale. What about Kelvin? Again, Kelvin is also name of a scientist. So what did Kelvin do? He took the melting point of ice as 273 Kelvin. I think, sir, where are these random numbers coming up from? There are reasons behind it, but very complex for us. For now, you can assume that Kelvin just took the melting point of ice as 273 Kelvin and he took the boiling point of water as 373. How many equal parts are there? How many divisions are there between melting point of ice and the boiling point of water? Everyone try doing it. How many divisions are there between these two? Right, for that you go for 373 minus 273. 373 minus 273. How much will that be? Yeah, that will be 100. So you divide the temperatures between melting point of ice and the boiling point of water in Kelvin scale into how many parts? 100 equal parts. You can write it down here. 370 minus 273 is equal to 100. So melting point of ice 273. The boiling point of water 373 Kelvin. Ultimately, everyone, you have to remember this. Is there any now many of you might be thinking, sir, is there any logic behind these numbers? There is, but very complicated for us at this stage. We will learn it in higher grades. For now, please remember this. Okay. So you have different units. You have degree Celsius, degree Fahrenheit, you have Kelvin. And for different units, we have different values. So these are scales. Units are different. And when we say Kelvin scale, its importance is this: melting point and boiling point. When you talk about Fahrenheit scale, then its importance is melting point and boiling point will be different values. Okay, different scales, they define melting point and boiling point as different. Clear? Okay, that's good, that's good. So let's go into a few questions then. What is the best way to know how hot something is? I'm talking about how hot something is. By touching it, by seeing it, by measuring its temperature, or any of the above. What do you think is the answer? What is the best way to know how hot something is? A, B, C and D. Yeah? The correct answer is, yes everyone, all of you are correct, that's wonderful. By measuring the temperature, option C. By measuring temperature. Good? Wonderful. Next. Which of the following is not a scale of temperature? Celsius, Fahrenheit, Kelvin, thermometer. Which of the following is not a scale of temperature? What do you think? The answer is thermometer. We have different units. We have Celsius scale, Fahrenheit scale, Kelvin scales. We have their corresponding units also. But thermometer is an instrument to measure temperature. So the answer is thermometer. Clear? Next question. What is the boiling point of water equal to? 100 degrees Celsius, 212 degree Fahrenheit, both A and B, neither A and B. What is the boiling point of water equal to? This is an interesting question. What do you think is the answer? Option A, option B, option C and option D. Yeah? The correct answer is option C, both A and B. See, boiling point of water. We have different values in different scales. Different values in different scales. Yes or no? Is equal to, in Celsius, 100 degrees Celsius. In Fahrenheit, 212 degree Fahrenheit. In Kelvin, 373 Kelvin. Got it? Good. Next. What is the melting point of water? Again options. 100 degrees Celsius, 212 degrees Celsius, 270 Kelvin, 32 degrees Celsius. So what is the melting point of water? Again, A, B, C and D. What do you think is the answer? What is the melting point of water? And the answer is option C, 273 Kelvin. Because when again, see, you have to remember the values in every scale, in every unit. So when we talk about melting point of water or ice, okay, then it is equal to 0 degree Celsius. Or in terms of Fahrenheit, 32 degree Fahrenheit. In terms of Celsius, 0. In terms of Fahrenheit, 32. And in terms of Kelvin, 273 Kelvin. That is the reason why it is option C. Okay. So that's it, everyone. So in today's class we learned about heat. What is the definition of heat? What is heat? Heat is a form of energy that flows from a hot body to a cold body. How do you measure how hot a body is or how cold a body is? Using temperature. Temperature is a measure of the hotness or the coldness of a body. What are the units that we use for temperature? We use degree Celsius, degree Fahrenheit and Kelvin. We learned about the melting point of ice and the boiling point of water also in different units. Okay, so please go through that, please revise them and please remember the values. Okay, thank you everyone. Thanks a lot.